For our lab, we have to describe something that we learned in Chapter 4 and relate it to a real-life scenario. So I'm Caitlin. I used to be on the volleyball team at UNCW, and so I kind of wanted to relate this to volleyball because that's kind of my life, and that's kind of something that I always try to relate things to because it helps me learn them. So one thing that I really thought was interesting in Chapter 4 was Newton's second law, which obviously I've learned about before, but just really relating it to the volleyball aspect has been really interesting. So in the book right here, it says Newton's second law, the alteration of motion is ever proportional to the motive force impressed and is made in the direction of the right line in which the force is impressed. Which, honestly, that's confusing. But essentially what I understood it to mean is as something is hit with a certain amount of force, it's going to be like repelled at that same amount of force, essentially. So, in the case of volleyball, I think of it this way. The faster, so Newton's second law really deals with acceleration. So, like, the faster a volleyball player is able to, like, swing and hit the ball, the faster that the ball is going to be able to travel. So, not necessarily, well, not necessarily, but the thing that most people don't understand about volleyball is that, like, you don't have to be really strong. Like, so, like, that would be the force. So the force doesn't have to be really, really, really high. Just the velocity that you're swinging your arm, so the faster you can swing your arm, is going to help with a result in a harder ball hit, per se. Another thing we learned about in Chapter 4 was Newton's third law, which is law of action. Hang on. Sorry. Newton's first law. Sorry, law of inertia. That one's easier to do. So every body preserves in its state of rest or of uniform motion in a right line unless it is compelled to change that state by forces impressed thereon. So essentially, an object stays at rest, or an object that is rest stays at rest until acted on upon by an outside force. So let's say I had a ball. I have one in here. But say I have a ball and it's sitting on a table. It's going to stay sitting on that table until force acts upon it. So, say I'm at a tennis match and there's a ball sitting on the sidewalk. The ball is going to sit right on that sidewalk until a force acts upon it. Let's say wind. So, a wind is a force. It's going to come and blow the tennis ball, which is going to consequently move it. So, that's a law of inertia. And one thing I think is really cool about inertia is, like, it said, and this was actually a question on our test, but that it's harder to get something moving rather than to keep something moving. So it's harder to move a ball rather than help a ball along its journey. I think that's really some of the main material that I can apply. I mean, you mentioned doing something like explaining friction between two different objects. Well, obviously, the one subject that's always talked about with friction is ice versus, I guess, concrete. I think that's the easiest way for me to understand it. So if something is sliding across ice versus sliding across concrete, there's more friction on the concrete than there is with the ice because of the makeup of the ice. So, like, a hockey puck is going to go further on the ice because of less friction instead of on a concrete surface. So, yeah.